Okay, so now we begin our proof that the sum of the measures of the angles in a triangle is always 180 degrees. So, the proof questions I always think are the most interesting because they're the real tests of our ability to like logically deduce things and generalize our results, and they happen to be more like intellectually stimulating, I would say. So I encourage you, please give this a shot on your own before you watch me go over it. But I'll just assume you've done that already. So let's get started on the proof. So this proof works with any type of triangle. You can replicate it with a right triangle, an acute triangle, an obtuse triangle, whatever. I'm just going to draw a generic looking triangle like this. So here's our plain Jane generic triangle. Nothing special going on right now. I'll label the 3 points A, B, and C. Okay, now my goal is to prove that all three of these angles have to always equal 180 degrees. Well, how can I do that? Well, if we look at what we did on the last problem, that seemed to give us a direction to go in, because one of the things we saw was that, okay, the three angles happen to add up to 180 because of these parallel line facts that we were using. So if we can utilize these same sort of ideas, then maybe we can prove the same results. So let's start by drawing a line parallel to, we'll use BC. So I'm going to take BC and create a line parallel to it. Now, where should I place it? Well, in the last problem, it was on that top vertice, so I'm just going to do the same thing. Place it right here. Okay. So this line is parallel to BC. Okay. Well, what was so important about the parallel line in the last problem? Well, the important thing was that we used alternate interior angles to show that certain sets of angles were equal, and that if you looked at the three angles on the top part, that they all equaled 180, and using that we showed that the angles at B and C would be also equal to 180 degrees. So I'm basically going to be doing the same exact thing. So, alright, let's look at this angle here at B. This is alternate interior with the angle up here, so that they must be equal to each other. And I'm just going to call 2 points over here, D and E. It'll make the proof a little bit clearer, hopefully. So, okay, angle ABC is equal to angle DAB because they are alternate interior angles. It might be a little kind of hard to recognize that, but again, the line that I created, DE, is parallel to BC. The interior would be this section here, and they're on alternating sides of the transversal AB. So using that, we can show their alternate interior. So angle ABC is equal to angle DAB. And we can show a similar thing with angle BCA. So this angle, I use 2 tick marks, is going to be equal to the angle EAC, the one right here. Why? Same reason, because they are alternate interior angles. So we have this, and we know that angle BCA is equal to angle EAC. Because they are alternate interior angles. Okay, so that's something we were able to show. All right, now what do I need to do from here? Well, in the last problem, we used the fact that we have a straight angle over here to show that the three angles DAB, BAC, the one right here, I'll use 3 tick marks for that one, and EAC would be equal to 180 degrees because it forms a straight angle. And again, we get that semicircle like angle from it. So that's something I can definitely state. Angle DAB plus angle BAC plus angle EAC is equal to 180 degrees because they form a straight angle. Beautiful. Okay. So, where can we go from here? Well, let's use everything we've established. We just shown that these three angles add up to 180 degrees because they form a straight angle. But what we earlier showed was that, like, for example, angle ABC is equal to DAB, and angle BCA is equal to angle EAC, which both appear in this equation we just wrote. So, if we use substitution, we'll get a new equation that involves the three angles of our triangle, ABC and BCA. So, by substitution, which I'll just put by substitution, we get that instead of angle DAB, I'm going to write angle ABC because I know they're equal. So we're going to substitute DAB for angle ABC. Plus angle BAC, that's fine. That's one of the angles in the triangle, so I kind of want to keep that. Plus angle BCA, which I know is equal to EAC. So again, substitute EAC with BCA. That's equal to 180 degrees. And that's basically it. We have the three angles of our triangle, ABC, BAC, and BCA. We have shown that no matter what those measures were, all three of them have to add up to 180 degrees. So beyond any doubt, we've established that. So now we know that for any triangle, no matter what, the three angles have to add up to 180 degrees. And since we've proven it, we can now use this idea in other problems, which I'll show in the next video. But again, these proofs are important because if you understand the reasoning behind why these theorems and ideas work, and you don't just like copy them down and memorize them as just sets of facts, you understand why, it makes it, first of all, easier to remember. And if for some reason you happen to forget, you have the skills to logically figure out these results on your own anyway. So it's almost like you don't even need to memorize it, although it's going to be easier to memorize because you've worked it out yourself. Anyway, that's about the end of this video. In the next video, we'll see some applications of how we can use this idea to solve problems. So I'll see you then.